Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll continue talking about model selection and we'll talk about tuning hyperparameters of an estimator. These are the topics that we'll go through. And in previous video, we looked at metrics and scoring methods. And in videos prior to that, we looked at how cross-validation works. So in this video, we'll focus on a layer on top of that, which is called grid search CV and associated methods, which can allow one to perform several cross validations using different parameter values. And that's where the parameter tuning comes in. So these parameters are called hyperparameters. And here is an example. Uh, in case of exhaustive grid search, the idea is that you provide a list of all possible values for the parameters in as such as shown here in a dictionary. So we have the list called parameter underscore grid, and within this list we have dictionaries. So the first dictionary has values for the parameter C, which is 1, 10, 100,000, and kernel is set to linear. In the second dictionary, we have the values for C, values for gamma, and a different kernel. So what the grid search CV will do then is it'll create the combinations, all possible combinations from these. So for example, linear with one linear kernel and then C is equal to 10. So here we have 4 combinations, and in this case we have a lot more. So one combination could be C is equal to 1, gamma is equal to 0.001, kernel is RBF, and the second one would be C is equal to 1, gamma is equal to 0.0001, and kernel is RBF, and so on. So this is the exhaustive method. So all possible combinations are tried in the cross validation, and then the best parameters from this grid that give the best score are then uh, shown as output. There is another method which is called randomized parameter optimization. So in this case, what the difference is that here instead of specifying values directly, we can also input distribution. So here for C, we are in the input is scipy.stats.exponential. So we are inputting an exponential distribution. For gamma also there is exponential distribution that can be used as an input. And now when uh, distribution is used as an input, then the algorithm will pick randomly data points from that distribution and use those as values for these parameters that we have C and gamma. Successive halving is another method to improve the efficiency for the search of uh, optimized values for hyperparameters. And what this helps do is, let's say uh, we have a combination of parameters that amounts to 90 or 100. If you do an exhaustive grid search, it's going to take a lot of time. So the idea with halving is that you you give a limited resources to the first few iterations. That is, instead of running the CV on the entire data set, you just give it first maybe 4 rows, 4 samples, and run all all the combinations of parameters, and then pick the best ones, uh, and then move on to the next iteration. The next iteration, you can pass in more number of records, but then the number of candidates, you can halve the number of candidates in second iteration. For example, in this particular plot, we can see The first iteration has 20 samples, so 20 rows, and n candidates is 35. So by candidates, this means the combination of the parameters. So for example, C is equal to 1, gamma is equal to 0.001, kernel is RBF. So that's 1, and then the second could be C is equal to 1, gamma is equal to 0.0001, and kernel is RBF. So uh, those are the combinations of candidates. And as you can see on the y-axis, we have the test score. So as the number of iterations proceed, so 1, 2, 3, 4, 5, 6, here by the end of last iteration, the number of candidates is only 2. So there are only 2 possible combinations of parameters used, and the number of samples is much larger. It's 640 records as compared to just 20. So this could help expedite the search for hyperparameters that best fit the data. Here, and this shows the implementation of HalvingGridSearchCV, and here we have the data X and Y. Let's say the classifier is a random forest classifier. In parameter grid, we can specify these 2 parameters that we are looking to optimize, which is max depth and min sample split. And here we specify 2 values, 3 none and 2 and 3. So when we in HalvingGridSearchCV, we pass in the classifier as an argument, the parameter grid as an argument, and resource is how many number of records do you want do you want the algorithm to pick in from the first iteration. So we'll talk about this a little more detail in coming slides. Max resources, and then this we can fit it on the data X and Y here, and after the fit is done, we can get the best parameters. So in this case, max depth none and min sample split 2, n estimators 3. So those are the best parameters that it found for this data. And here we have, so this was HalvingGridSearchCV, and now we have HalvingRandomSearchCV. So in random search, uh, as we saw earlier, we can pass in a distribution. So here for min split, instead of specifying 2 and 3, we are saying uh, random integers 2, 11. So the algorithm will pick values randomly from that and use that to fine tune the parameters max depth and min samples per split, min sample split. And here we can see after the fit is done, we can get the best parameters in the same way. We have max depth none, min samples split 5, and n estimators is 3. And before we move on, I just want to mention that there is an option of aggressive elimination. So you can set it to true or false. If you set it to true, then what it does is it forces the algorithm to use least number of candidates, so least number of combinations towards the last iterations as the iterations proceed. So basically cuts down on the number of combinations that would be available for next iteration. Now, 2 parameters that are important to understand in when performing the halving grid search is resources and candidates. So by resources, I mean the number of records, and candidates means the number of combinations of the parameters within the grid. So let's say we have we set the min resources to 4. That is to say that in the very first iteration of the halving grid search CV, the algorithm would pick only 4 records. Then if we set factor to 3, and if we have the total number of candidates equal to 90, then this table on the right hand side shows how the algorithm would proceed. The first iteration, it'll pick 4 records and work through all 90 candidates, that is all 90 combinations of parameters. In the second iteration, it'll pick more records, so 12 records, and will use only the best 30 uh, candidates, and so on, and towards the last it will use only the 3 combinations and use lot more resources, that is lot more records, that is 72 as compared to 4. And the resources that are specified here, resource, it can also be uh, an output from an estimator. For example, if you are using random forest classifier, then n estimators can be used as a resource, as an input to resource when using HalvingGridSearchCV. And as we talked earlier, what happens is in the process of halving, it's sometimes possible that some of the data is never used and or left out if the settings for factor and if the settings for factor and resource or min resources used is um, not set to kind of use all the data. So if you want that to happen, that the algorithm uses all the data, then this parameter can be set, the min resources could be set to exhaust, and what that will allow is, as it goes through these steps where it uh, reduces the number of candidates and increases the number of resources, it will do it automatically such that if you have 100 records, it will use all the 100 records. Whereas if in this case, let's say if there were 100 records, then only 72 were used, the rest were not used. And aggressive elimination of candidates. So this is what I mentioned earlier. It forces the algorithm to uh, work in a way that towards the last iteration, there are very few combinations of parameters remaining to be tested on the available data. And finally, the output can be brought into form as shown here by using the attribute CV underscore results. And here we can see that this can also be converted into a data frame for further analysis. And we have iteration number column, we have n resources, we have the mean test score. You could use this to create a plot, and maybe based on the shape of the curve that you get on the score as the iterations increase or as the number of resources increase, you could pick a range as to what parameter values work best and then use those in downstream processing. And finally, for tips for parameter search, these are fairly obvious, but some of them may not be. You definitely want to use an objective metric. So for classification, generally the accuracy score is used. For regression, R2 score. And you could also specify multiple metrics. It could be in form of a list or dictionary that can be input to the grid search CV. And then you can see which score matters more when selecting a particular value for a particular parameter. The grid search CV also works with pipeline. So if you have a pipeline such as shown here, pipe, Uh, what you want to do is create a parameter grid as shown here, which can be a dictionary. And in grid search CV, then the input would be the pipeline and the parameter grid, along with how many fold cross validation needs to be done. So that can be fit on the data. Finally, for model selection and development, and evaluation, what we have seen in so far is that we split the data set into train and test set. We don't touch the test set, and we perform the cross validation on the train set, or we could also split the train into validation set. But if we are using cross validation, then we would be using the folds, so splitting it further is not needed. And that's the idea here. So you definitely want to do the development work, that is finding the optimal values for the parameters on a set that is completely separate from the evaluation set, which would be the test set that is never seen by the training process or grid search CV or cross validation processes. And Scikit-learn does offer parallelism, perform parallel running of the algorithm. And to do that for grid search CV, we can specify n jobs is equal to -1 to perform a parallel processing of the data. And as far as I know, with Scikit-learn, we cannot use GPU, but you probably want to check that there are any updates. So this would be based on the cores in the CPU. And tips for parameters search robustness to failure. Here we can see that as the setting, we can set the error underscore score to 0, and what that does is it will make the procedure robust to failures. uh, what I mean by that is, let's say if you have values for parameters for C, you have 1 2 3 1 and so on, but if there is a value that is not a value that should be used as an input to that parameter, then it will throw an error and the run would crash. So to avoid that, you could specify this particular value for the error score, and in that case it will the algorithm the out it will show a warning that this was the problem while running the grid search CV, but it will continue to run with remaining uh, candidates or remaining combinations of parameters in the grid. So this is really helpful. And alternatives to brute force search. So brute force search meaning you're searching each and every combination. Models, so there are models such as ElasticNet CV and others listed in here that use the regularization path to find the optimal parameters, and those could also be used. So if you want more details on this, you can check out earlier videos in this series. We go in much detail in discussing these. So that's an option. And additionally, to check the model fit, there are two more criteria, which is Akai-K information criteria, AIC, and Bayesian information criteria, BIC. Those could be used to uh, those could be used for model selection. And here, this is the example shows Lasso Lars IC. Out of bag estimates is another useful way to kind of use most of the to get most out of the data. And probably already know this. Let's say if you are running a random forest classifier, and if there is part of data that is left out, then what one can do is the trained model could be tested on the data that is left out. So that's how left out portion from the model training can be used to uh, optimize the parameters. And that was it for this video. I hope in this and the previous videos you got an intuition about cross validation, matrix and scoring, and now grid search CV. And together this becomes a very powerful tool to optimize the models that you create and find the best parameters in while developing these models. Please like, share and subscribe. I hope to see you all in the next video. Thank you.